all the areas, it has to be 900 long, but at the spacing of 800. Okay, so this is the style that we have to give it. So why I'm telling it is, if you give it like this, the quality of making it at the site will be very easy and without errors. And most of the time we see that people give it in schedules. Just they will group it to S1, S2, S3 like that, and 3-4 slabs, and they will give just LX and LY long. Also, they follow this in the beam design and detailing. The problem is that many of the things cannot be very simple. There can be many reasons why we are giving it like this. We can play with all these possibilities. If we detail it accurately, we are actually detailing to save the reinforcement also. So I was I was telling that when you don't give it, if there is a major error, that will result in cracks. For example, at the support, it's a hogging moment, so the reinforcement has to be based on the support moments. So I'm just telling you a brief explanation about this so that you can give it nicely. So like that, the beam reinforcement also can be done. You please, Rindu, please take a beam reinforcement also. Anything will do.
So is this
So
clear?
yeah, this is okay. Yeah, you just take a beam reinforcement. I taken the next one where it is continuous. Beam reinforcement is continuous. Maybe you have not completed to the design side in the college, but I'm just giving you what to do, how to do, why you should do it perfectly. Yeah, this is a particular longitudinal section. This we will be drawing in CAD, AutoCAD. So here you can see the reinforcement are neatly drawn for a complete section. Okay, and it's showing different things. What are the showing exactly the width of the column, dimensions of each bus, number of each bus, a leader showing where it is connected. All this is perfectly drawn. So in a project, there will be hundreds of beam like this. So we need to actually draw everything. So when you study the moment and shear, the reinforcement will be exactly matching to these requirements. So if you look at the ETABS, there will be a lot of cases for every beam. There will be a lot of combinations. That is dead load plus live load, dead load plus earthquake, dead load plus wind load. Then the combinations of different combinations as per the code. So when you are designing a beam, you will be actually looking at every code, every codal value, every combinations, and you're preparing your drawing based on every combinations. So this will be how a drawing should look like. Here also, why I'm just telling you why it is important is to make once you make such a good drawing, then you can take the bar. You can make the bar bending schedule out of this. Bar bending schedule is nothing but the length of every bar, the shape of every bar made into a schedule. So once you draw that, you can use the system to make a bar bending schedule. So based on the bar bending schedule, they can cut the system and cut the bars and assemble it the site correctly. Even cutting and bending operation can happen even before the formwork is done. So even only if you do it correctly, you can even make a BBS, or you can actually save the time at the site. Okay, so I just shown you what are the types of detailing done. So I just shown two members for example, that is a slab and the beam. So like this column, pile cap, all these things has to be done, whether it is, if it is structural steel, you have to do it like that. So, there are a lot of possibilities. You have seen structural steel drawings also. So I'm not going into. So I'm just telling you, we need to detail. We need to actually draw it correctly to execute the same at the site. And this will be the basic. The drawings are the basic place where we now communicate to the site. Okay. So if we if we understood what it is, so I'll just also explain it is, for example, 220 means 220 bars, which is going up to that. Then 220 extra is, which is coming at the next level or the next layer in that area. In the bottom, you can see 8 at 100, 8 at 150. These are the stirrups. Stirrups being used in the beams. Okay, so this is what usually is drawn in a beam. If it's a instead of a two-leg stirrup, if it's a four-leg stirrup, we will show like that. Okay, 300, 600 is the size of the beam, and B1, A11, etc. is the naming given to the beam. So this name will be in the layout also. So you look at the layout, and that beam's details will be given as a section. And you can also give the sections of these beams also. That is cross section of, this is a longitudinal section. Is there any cross section here? Yeah. You can place the cross section. You just zoom to the cross. This is the layout. This is the layout I'm talking about. This is a big project, maybe 20 story or 15 story. So just show the layout first. This is a cross section. This cross section can be even given for the by showing a section of the longitudinal section also. So the earlier one you saw the longitudinal section, you can cut there and show a section mark and give the sectional drawings on the other side also. So I am showing this is, some people will only give like this, which is easy for them. That is B1, C1, just a section, and it will save time for them. But the problem is there will not be quality. In the longitudinal section, it will not say where to cut the bars, where to lap the bars, etc. So there are things like, you cannot lap the bars in a place like bottom beam in the midspan. Like that, you cannot splice a bar in the top side where it is support. In the support, because the working moment is at the top, so that you should not splice the bar. So such details will be missing in this. So without a longitudinal beam section, you should not give like this. So this will all adds to the quality of the construction and adds to the improvement, adds to the quality of the construction and to the cost of the construction. So this is why I said like we should have a fine detailing. So like that, everywhere the detailing aspects are there, which will help in the total project management course. Okay, so Rindu will explain more to you on the PBS side, how the PBS is extracted, how the, a small presentation will be there after this. Okay, so let's go to, now I will share my screen. So you're able to see my screen. This is the longitudinal section. So in this bar, if you add the numbering also, this number detail will be available here on the right side in the schedule. So for each bar, information will be given neatly there. Whether it is a bend bar, whether it's a straight bar and all, you can get from the bar bending schedule. So it will be This bar information will be connected with the schedule. This is called BBS. So it's nothing big in this. Only thing is the detailing aspect. When you study into these things, it will be very interesting. That is the combinations. So different combinations are worked out. They are designed as reinforcement. They are actually detailed correctly, and then you can name it correctly and get a reinforcement like that. But the problem in Indian scenario is that very less people are actually doing this correctly. So it is affecting the quality of construction, and it is affecting the cost of construction. If you're just giving a B1, B2 like section, you will be providing steel where it is not required. It will be a general section or grouped section. It is not required in most of the cases. So here only at the top you require extra bar. At the bottom you don't require extra bars. So in the longitudinal section, you have a chance to detail these things separately. Okay, so let me tell you what are the advantages you can get from better detailing, a better bar bending schedule, and better estimation. So one thing is that when you are using FE 500 or FE 550, bending and other thing is very important. You cannot acutely bend the bars like 450. If you acutely bend the bars, it will reduce your strength. So if you only prepare the bar bending schedule and the curvature is maintained as per the exact geometry, you can bend a bar. Otherwise, if you don't bend it correctly, it may go out of the system and all, like out of the formwork. Why I said is for FE 500, you should have a bigger radius of curvature. So for bigger radius of curvature, if you don't calculate the length of the bar in earlier, if you do trial and error, it may not be coming correctly. It is okay when you do 415 bar. When you accurately bend it, it is okay. But in FE 500 and all, as the bend diameter is high, you have to actually calculate the length of the bar based on the radius of curvature of the bend portion. So that is a thing, that's a quality that is usually maintained when we go for construction abroad. So we don't look at that kind of quality, and what is the usual method for breaking a bar? If you bend it twice both ways, it can break. So bending action is always reduces the strength at the bend section. So to avoid the bend section reduction in strength, they are supposed to be bent at particular diameters. So that is different for 12 dia, 16 dia, 20 dia. It is all different. So we will have to do it like that as per the code. The code for this is 2502. Code for bending is by IS 2502. So if you refer to that, there will be a lot of things mentioned, like what is the bar diameter, bar bend diameter to be used for a particular bar like 20 dia bar, which will be higher than the 16 dia bar. So another advantage is with a proper BBS, you can cutting and bending can be done separately in a factory or in a different site. But presently, our big problem is that people only do the cut and bend only once the formwork is done, because they don't have the geometrical information. So if you can manage a geometrical information in a CAD-based system, you can cut and bend your bar earlier, even before the formwork is done. So if you can maintain that, you will be saving time on construction. So all these things is basically a function of why function only if you do proper drawing and detailing correctly. Okay. So then I was telling, there is a general tendency to group slabs and beams like S1 and S2, B1, B2 like that, cross sections. If you group like that, lot of money is wasted and lot of quality may be wasted. as I have shown in the earlier drawings. So better quality control at site is there, better estimation of steel is there. The other side estimation, to do the estimation will be easy, but you will be actually spending a lot of money. Okay, here another aspect is if you do the BBS, you exactly know what is the quantity required, better control on stock of steel actually required. These are the other advantage. So you can benchmark your design with respect to another design. So if you have the exact quantity of steel, you can actually save when the next project is coming, you can say, okay, for this kind of project, the quantity of steel could be something like this much kg per square feet. So such things are possible. So this is benchmarking with respect to quantity between different projects. So as I said before, if the formwork, before the formwork, if we can do the bending and cutting, it can save a lot of money in a lot of time in construction. For example, in India, we will be taking around 15 days to do the project per floor. Per floor, RCC construction takes up to 15 to 20 days. Whereas if we go abroad, it is done only in less than 10 days. Burj Khalifa was done in 7 days. So this is the time saving. So instead of 20 days, if you can do in 7 days, you will be saving 13 days per floor. And 13 days into say 20 floors is 260 days. That is almost 1 year saved just by, doing the BBS. So that's very, very important. Okay. So these are the indirect benefits you get from better detailing and better drawing. Okay, and also you can exactly mimic or have a copy of the drawing. That's what you see in the site is what you get. What you see in the drawing is what you get that site also, because it is almost the same. And the accuracy, accuracy you have to maintain is very, very high. Because even if your bar is just 3 centimeter bigger, that is on a 12-meter dimension, if your bar is just 3 centimeter more, it will not fit in the formwork. So if you bend it earlier, you must have, quality maintained to that level. So that's very, very important in BBS construction. So this is one aspect. Okay. So, this is what I wanted to talk to you basically about it. So anybody has any questions, you can ask me. Okay, I talked about some of the aspects of detailing and the BBS at the site. And there are a lot of structural engineering aspects you have to understand when you actually study the subject. When you study the subjects, you also study the different codes, different detailing codes. For example, SP34. SP34 gives a detailing of reinforcement of different types of members. So that will be very important. You can just take a note of it. SP34 will help you how to give bars in every type of members like footing, pile cap, retaining wall, beam, slab, everywhere. How you have to maintain the thing. Then you have to surely do this detailing based on the codes only. Codes is IS 3920 is required for detailing, ductile detailing, and IS 456 all gives you the basic design detailing requirements. So you need to study those things in detail and actually you have to practice it also. Then only you will get a taste of how to give the reinforcement correctly. And many times, the simple detailing things, if you don't know, you can land up in big cost. For example, suppose in a beam, you have 320 diameters on one side and the other side. Suppose your beam joining to the column is, big. That is, if the development length, how many of you know about development length? Anybody know development length, LD? Development length is a very important thing which you will hear in your career. Development length is nothing but the length by which a beam bar has to enter into the column. Okay, so it is, it ranges from 40 to 50 times diameter. So if it is 20 bar, 1 meter has to go inside. But if the column size is not big, what will happen? You'll have to bend the bar. But if the column size is, say, 120 in that direction, you can just put the straight bar. Okay, like this. If the column size is very less, you have to actually bend the bar. And suppose think in one particular site, it's a 20-story building. 20-story building, one side is a big column. You please consider. So you have enough space, you don't have to bend it. But if you don't know that rule, you will think that all the places you have to bend. So what happens? So 3 bars you are going to bend unnecessarily. So that is 3 bars, just one, mistake. So let's look at the cost now. You are also grouping, say, 10 beams as B1, and there you are doing this mistake. So 3 bars will be 2.5 kilo. It will be, say, around 7.5 kilo on one side. And the other side is also 7.5 kilos. So it's 15 kilos on a simple drawing, on a beam drawing. But remember, there are 10 other beams. So it is going to be 150 kilo wasted on that simple mistake. And not only that, if you are doing that mistake for 20 floors, it is going to be 3,000 kilos. And that simple mistake will have an additional cost of 3 lakh rupees in a big project like 20-story project. So the important point is that you have to know how much you have to bend the bars, what are the rules everywhere. If you follow these things correctly, you can save on the material and you can ensure the quality. And such things happens everywhere. Every places, this is for our different members, such detailing things and everything is very, very important. And nowadays you have beautiful software systems which can almost tell you what are the possibilities. How much you can see the deflections of a beam, serviceability, strength characteristics, what are the reinforcement required, and all these things. And presently, we are working on a system where we are exporting the reinforcement from the tabs directly to the Revit itself. So we are now successful in doing that. That means we are exporting everything into a 3D form. Do you have anything now to show? Otherwise, you can show it later. Maybe some figure of the where we get the column.
No, sir, the system is down and there was an update done.
Your side. Okay, no problem. So we'll in the one of the next classes, we'll show you where once done in ETABS, the entire thing flows back to a 3D Revit, where you can actually see this in 3D. Previous to your generations, nobody has seen that. Simple as that. Or in very, very Maybe coin not 1% of project people would have seen. People have taken pains to do that, but it is possible. So you're actually going to visualize things on a 3D platform. So that's going to be the future for you. So you can, all you are following rules in the 2D dimension. Now you can follow it in 3D dimension also. So there are a lot of possibilities coming for everyone. You need to learn 3D packages, 2D packages, like, Revit and all. So most of you know that, Revit costs around 1 lakh for one package. Like that, many Revit connected softwares are there. So all these softwares are free for you. You can download freely from the web, and this costs 1 lakh. If you want to practice it after your education, you have to spend 1 lakh every year. Maybe you can get pirate software. I don't say about that, but nowadays, piracy is stopping. So I mean, reducing. It's not possible because of the cloud-based system. So in the future, you can actually, it's a good time to learn it now. Maybe in the future you don't get time or the chance to learn this thing. So I suggest you learn Revit and other softwares also, where you can, get the things completely, not only the reinforcement, everything about a project in 3D, which actually improves the total manageability. Okay, so this is another thing which I wanted to discuss with you. So I have discussed about the code. I have discussed about some of the software side. We'll just show you some of the things later. And this is, this is a preliminary, or the basic information of how we should do things, we should learn, how we should get into these things. Most of the we are only guiding you in things. The job of learning you have to do. You have, once you do that, you get chance to actually work on the projects. Those who, are good, those who shows interest, they get a chance to go through the projects, work through the projects. Somebody's interested in the structural side, they can practice some projects. There are a lot of possibilities. So show interest, study these things, and come out for a project management. So thank you for your time. If you have any more questions, I can answer. Otherwise, I will conclude.
So do we have a demo on DBS today, or are we winding
Yeah,
up?
you can just show some of the some of the aspects. Just in 20 minutes, you can just close it, or 15 minutes.
Okay, so I'll just cover
As
for
a
the main
continuation of
parts.
my talk, you can just have a discussion on how to do that. You
Is my
can
screen?
okay. So I will conclude. Thank you all. Thank you, bye.
Thank you. Is my screen visible?
Yes,
Sharon?
yes,
Yes.
yes,
Okay, so
yes. Visible, visible.
now this is a sample beam DBS. Okay, this is a layout of the entire floor. And as I mentioned earlier by sir, these are the longitudinal sections, and here we have the cross sections. Now from this, I'm just taking a sample, a draft sample, a simple one, not a very complex one, just for ease of understanding. Okay. Once you get the drawing, it might not be completely perfect. There will be some corrections or checks to be done. You have to check the span between the beams, the size of the column, the rebar drawing, is it polyline? All these factors have to be checked. You have to check whether the leader is properly touching the rebar, otherwise it won't be recognized. Now this is the leader line mentioning that there are 3 numbers of 20 bars, and here we have the stirrups, 10 dia at 100 spacing at the support, and even in the mid span. Okay, once you complete drafting, you have to open Aadspro. Now, this is how you prepare a bar bending schedule using a software. There is physical methods where you draft the entire thing in AutoCAD, but this is the alternative simple method. Okay. Now you will be learning the software. Don't worry. You have to set the properties. Now, since we are scanning a beam, the beam tagging must be B. You have to fill in the development link, refer the same from code, and you have to enter a bar mark start. You have to select the code and other data to be filled in. So for time being, I'm going with the default values and make sure that the reinforcement layer is properly selected. Otherwise, there won't be any information scanned. Okay. Now we'll go to the scanning part. Click on scan drawing. Go to the drawing. Go again. Okay. Now you see earlier the cursor was a crosshair. Now it has changed to a box shape, indicating that the system is ready for scanning. Now scan. And in the background, you can see that in Aadspro there is some changes happening. And in the drawing also, there's something changing. You can see that there is a number added to the tail of the leader marks. And this indicated that, and the cursor has returned back to the square shape. Now click escape and just check in the Aadspro page. Here you can see 600, 601 and 602. These are the bar marks. And the first one is a stirrup. And we'll just export this to AutoCAD and see. A bar bending schedule is nothing but a table where we can see the shape of the bar and the length to be cut or bent. So cutting will be for the total length of the bar and bending will be based on the individual length marked in this image. Okay, so this will help any worker, skilled or unskilled. If they're able to read and write, then they can easily read, understand, and cut a bar and bend. So even the unskilled laborers can be made use if we can supply a proper BES sheet. Okay. Now you can see the bar marking. The same bar marking is also given here. I didn't mean that you have to use unskilled labor. If skilled labor is limited, you can also make use. Okay. Now you can see the bar mark and the bar corresponding data is here. Okay. There are three number bar marks, 601 and 2. Similar bars will be grouped under the same bar mark. If it's a long beam and there are similar bars at different sections, then they will be grouped when you scan it together. Okay. Now this is a sample beam BBS. I just wanted to show you. Now we have done this for one section, launcher section. You will have to do it for all the beams in a floor. You think it's a tedious process, but comparing to preparing an entire BBS session manually, and there are chances that you can make errors more than 50%. So, and here there are percentages limited, maybe 1% or less than 1%, because the system won't go wrong while counting or checking the BBS. Okay, we can make mistakes, but the system won't make mistakes that easily. Okay, we can do very long spans, very short spans, complicated spans can also be scanned. So there is no limitation for the software. Now, similar case when we come to a slab BBS part. Firstly, there will be a supply drawing which will be supplied by the structure engineers. So this is one that is supplied by them. There will be minute corrections. Corrections means not the bar corrections. You will have to correct the layers. Okay. The main logic behind or the function happening while you scan is that the layer name and polyline tag will be identified by the software, and based on that the scanning or the table preparation is done. So you have to maintain the layer and the polyline. It should be a line or polyline as corrected. This is not corrected one, so it is a line. This will not be scanned once you scan it through Aadspro. Okay, you have to do the corrections properly. You will have to place the leaders properly. There are a lot of corrections to be done at times. Sometimes it won't be that much. Okay, once you get the drawing, check for whatever corrections is to be done. Do that. and then prepare the correct drawing. Take a copy of it. We'll just take copy of the top bar. Then I'll be scanning just a portion to speed up the things. Okay. Now, for scanning slab, you have to go for a separate option. Beam and slab are two different approaches, so you have to go for two different options also. Slab scan. Automatically, the results will be erased. So, if you want to save the results, you have to export it properly. You have options for exporting to AutoCAD as well as to Excel. If you're exporting to Excel, you will have something like this. Okay, you'll have a report. There will be a BBS detail sheet. You won't have the image, that is the shape won't be available, but the values for cutting and bending will be available, and there will be weight details. As mentioned earlier, when you take estimation, you will require the steel quantity. The total steel required for this project is given here. Okay, this is in kg. Now this is not the same project I am showing, this is just a sample from another project. Okay, now we'll just scan the slab. Here too, we'll have to set the properties. Okay, after setting the properties, we'll be just scanning. Come to the drawing. Since I'm opening multiple files at a time, I'm having this problem. Okay, now we'll just scan a small portion here. You will have to select the rebar as well as the dimensioning. Otherwise, it won't be scanned. Both are important. Okay. Now background, you can see the scan progressing, and we'll have the results coming up. Now, okay. Our system is free. You can go back and see the results. Let's export the BBS. From here, export. Okay, I should have exported somewhere else. Okay, I'll just export somewhere here also. Now, don't worry about this. This is the automatic dimension type. You can just change the type to another, and you'll have the proper dimension. Okay, so don't worry about that. It's just based on the dimension type you select. Okay. Now here also you can see there will be a bar mark. There will be total length available where you have to bend. That will be given, and a shape code will be also given. Okay. Now all these bars are L-shaped. So they are having the same shape code 37. Shape codes are based on the IS code 2502. Okay. Now the similarly you can export the results to Excel, and for doing that you will have an option here, export to, or instead of AutoCAD, if I'm taking Excel, you'll get it. Okay. Now the file is open. You can see you have BBS details as well as the weight details. Now show a sample BBS document. Now this is Beam BBS document. The first page will be the general slab layout, wherein you can see the name of each beam properly mentioned. So if you look at a beam name here and go to the drawing, next page, you can find the similar naming and as well as the detailing. Okay, that's the idea. So the first page should be the general layout. The next page will be detailed longitudinal layout. This is the way we supply these documents. Okay, then after the longitudinal layout, we'll have the bar bending schedule table format, wherein you have the shape of each bar, the length of bend, and the total length at which it should be cut. Now, at the end, you will have the weigh details. So this is for purchase. Purchase side, how what kilo of material to be purchased, which bar, which how many kgs to be purchased. So all these details can be obtained from the weight details. Okay. Bar bending schedule is for cutting and bending the bar at site, and the radiators for purchase and um, maintaining the store. Okay. Now that's all for the sample side. I hope you're clear